Hi all, welcome to another video of electrical machine design based on the KTU syllabus. So in the last videos we just discussed some problems uh, based on the design of induction motor, three-phase induction motor. So today also we are designing an induction motor, that is we are mainly finding its main dimensions. Okay, a problem. So the main problem is find the main dimensions of a 15 kilowatt 3-phase 400 volt 50 Hz 2810 rpm squirrel cage induction motor having an efficiency of 0.88 and a full load power factor of 0.9, and assume specific magnetic loading is equal to 0.5 Weber per meter square and specific electric loading is equal to 25,000 ampere per meter, and take the rotor peripheral speed as approximately 20 meter per second at synchronous speed. So these are the given values. Okay, so we have to find the main dimensions. Of course we know the main dimensions is found from using the equation, that is the input kVA Q is equal to C0 D square L ns, where this C0 is the output coefficient, and we know that the C0 will be equal to 11 BAV AC kW into 10 raised to minus 3. Okay, so this is the value of C0, and D, this is the diameter. Actually it is the diameter of the inner diameter of stator bow, and L is the length of the core, and ns is the synchronous speed in RPS. Okay, and Q is the input kVA, we know. So we have given it is a 15 kilowatt motor, so it is the output of the motor. Okay, so from that we have to find this input kVA. For that the efficiency, we know efficiency is given and the power factor is given. Okay, and C0 we can find using the equation. BAV is given, that is specific magnetic loading is BAV, and specific electric loading is AC, and kW is not given, so we can assume the value of kW as 0.955. Okay, and ns, okay, here the speed is given as 2810 rpm 2810 rpm. So we have to take the ns as, actually we have to take the ns as near to the synchronous speed. Okay, that is the synchronous speed near to the given rated speed, that is 2810. So normally we know for a 50 Hz motor the synchronous speed levels are 1500, then 3000, like that. So near synchronous speed is 3000 here, so that value we have to take as capital ns. So small ns will be capital ns by 60, that we know. Okay, so now we can do the problem. Okay, and here the first step is to find the Q, kVA input Q. We know that kVA input Q is equal to, that is output. Okay, output in kW. Here the kW value is given, kW into eta, efficiency into power factor. Okay, so this is the equation. 15 by 0.88 into 0.9, we will get Q as 18.94 kVA. It is in kVA. Okay, 18.94 kVA. After that we are finding C0. So 11 kW BAV is into 10 ratio minus 3. So here kW is assumed as 0.955 and BAV is 0.5 and AC is 25,000, and we will get C0 as 131.3. Okay, and we know that the speed of the rotor at full load is 2810 rpm, it is given, and the nearest synchronous speed corresponding to 50 Hz is 3000 rpm. So we have to take the capital ns as 3000. Okay, 3000. So the small ns will be 3000 by 60. Okay, 3000 by 60, that we know. So we will get it as small ns as 50 rps. Okay, 50 rps. Okay, and from the equation Q is equal to C0 D square L ns, we know that all other values we know, and from that we can find this D square L. Okay, by simply rearranging, we know the value of ns, we know the value of C0, and we know the value of Q, and by simply arranging we can find the value of D square L, that we can see here. D square L equal to Q by C0 ns, and we will get D square L as 2.88 into 10 ratio minus 3 meter cube. Okay, so this is the value. Okay, that is 0. We will get 0.00288. Okay, like that. Okay, that is 2.8 into 10 ratio minus 3. And after that we have to separate this D and L. Okay, so here for separating this D and L in the question, there is no it is not mentioned anything about the L by tau ratio, that is pole proportion ratio, L by tau and such that. Okay, so the only thing mentioned is the rotor peripheral speed. We have to take the rotor peripheral speed as approximately 20 meter per second at synchronous speed. Okay, that is the only value we know. So we know that the peripheral speed equation VA, okay, VA equation is peripheral speed VA is equal to pi dns, that we know, pi into d into ns. Okay, so here the VA is 20 meter per second, that we know, and d we don't know, so we can find using the equation the value of d we can find, and ns we know. Okay, so by simply rearranging, d is equal to va by pi ns. So va is 20 and pi into ns is 50. Okay, so we will get it as ds 0.1257 meter, and after that, by substituting the value of d in this d square L equation, we can find l as 0.177 meter. Okay, so that's about the problem. I hope all of you understand how we can separate the value of d and l from this peripheral speed equation. Okay, so thank you.